Let's look at number 38, the very first one in the multiple choice review. This one comes from the practice test, so it's very realistic for what we'd expect on the AP exam. In this one, they're talking about photoelectron spectroscopy, which is PES, and they're wanting us to explain the difference in the location of the nitrogen 1s peak versus the oxygen 1s peak. So you notice all the other orbitals aren't being shown. And let's look at what the information is saying. The information is saying that the oxygen peak is at about 550 in its binding energy. In other words, it's held much more tightly. So with the 1s being the lowest energy orbital, we're kind of mixing our models, but you'll notice over here I've drawn a nitrogen model and an oxygen model. These are Bohr models. The 1s is going to be the one closest to the nucleus. So it's going to be this electron and this electron. And for some reason, this electron appears to be bound more tightly than the one in nitrogen, so less tightly. And so that's what the data is showing us, and they're looking for an explanation of why. And I think we can see in these two diagrams exactly why. It's not going to have a lot to do with shielding or anything like that because both of these electrons are right next to the nucleus. But in nitrogen, it only has 7 protons, and in oxygen, it has 8 protons. It has higher effective nuclear charge, which will pull the electron in tighter and bind it closer. So the correct answer here is going to be D. Nitrogen atoms have a smaller nuclear charge than oxygen atoms. They do. They only have 7 versus 8. Now if we look through the incorrect answers, let's work our way up. Electrons in the p subshell of oxygen atoms provide more shielding than the electrons in the p subshell of nitrogen atoms. Now I haven't drawn a filling diagram model, but remember the p subshell is going to be in the second energy level because 2p is the first one. These cannot provide more shielding to an inner electron. You remember inner electrons, they don't experience any shielding because they're right next to the nucleus. So shielding is not going to be an issue here at all for those. Let's look at B. There are more electron-electron repulsions in oxygen atoms than in nitrogen atoms. Actually, if there were more repulsions between these two, it would probably make this one less tightly bound and would cause its binding energy to be even lower. It might be over here instead. So that's not a reasonable argument. And the top one about half p subshells, there is some logic behind this, but generally speaking, we don't do half subshells in AP. So it's just kind of a misleading answer.